Okay, so Chapter 3, Section F, page 94 reading. Up until now, we have learned how to evaluate, y equals b to the n when n is, and the answer to this is when n is rational. Okay, so pretty much we've been using whole numbers, but sometimes we use things like 3/2, fractions, right? So rational just means it's a fraction with an integer on top and an integer on bottom. What are the possible values of b for the equation to be exponential? Well, b can be almost anything for this to be exponential. The only thing it can't be is it can't be 0, right? Because 0 to the whatever is always 0. That's going to be a line, a really boring line. And the other thing that b can't be is 1, because if it's 1, then it's just going to always be 1 multiplied times itself, and that's also going to turn out to be a boring line, y equals 1. So b can be anything except for 0 and 1. So we'll just say, yes, b can be like any real number except 0 or 1, and then it will be exponential. So if it's anything negative, well, and then there's the case of negatives, which gives some really weird results with exponentials too. So we cannot be negative either. So change that. B is greater than 0, and also that b cannot be 1. Okay, so if these two things are satisfied, then the equation y equals b to the n is an exponential. Okay, to find y equals b to the n for any n, then we should look at graphs of exponential functions. Okay, so if we look at a graph, since a graph is continuous, it'll give us results or solutions for like any y or any x pretty much. So let's look at the case of 2 to the x. Okay, and we're going to calculate values of y for these y values of x. And some of these we can do by hand, right? 2 to the 0, of course, is always 1. 2 to the 1 is 2. 2 squared is 4. 2 to the third is 8. 2 to the negative 1 is 0.5. 2 to the negative 2 is 1/4, so it's 0.25. 2 to the negative 3 is 1 over 8, so that would be 0.125. 2 to the negative 10, that would be, negative 1 over 1024. I don't know what the decimal representation of that is. 2 to the negative 50, 2 to the, and we can just calculate it here, negative 50. Wow, that's tiny, huh? 8.88 times 8.88 times 10 to the negative 16. Okay. What value of y is the function approaching as x approaches negative infinity? Let's see. So if we see like when x is negative 10, it's already a pretty small number. It's about 0.001. X equals negative 50, it's already at 0.00015 zeros, and then you get to an 8. So x is obviously getting very, very close to 0. So let's say it's 0. What is the equation of the horizontal asymptote? Well, if y is approaching 0 as x approaches negative infinity, then the horizontal asymptote would be y equals 0. Because that would be the horizontal line that the function is approaching. And if we look here, I didn't show you this, but you see it on your paper. The points we've put here, such as 8, 4, 2, 1, 0.5, you can see them graphed here on this continuous graph of 2 to the x. So we've only shown you like obvious points that are integers, but this makes a smooth curve. So like any point in between these points is also a solution of 2 to the x. It's just not necessarily a whole number, not necessarily a rational number. Okay, so it says here, just think back to our Desmos investigation about the role of each of these numbers like C, K, and D, and we're going to use that later during our problem solving here. So now this is the same graph that we just saw above, but it's showing you how you can use the graph to find solutions that are not whole number exponents, for example. So we have a couple questions here. The value of 2 to the x, we're given value of x, for example. Let's find the value for 2 to the 1.8. You know, 2 squared is easy, 2 to the first is easy, but 2 to the 1.8, that's not so easy, right? So we're going to use this graph to figure that out. So we find out where 1.8 is on the x-axis, and then we just trace it up, and we intersect the graph, and then we go over to the y, and we see that it's about 3.5, right? So 3.5 is a solution for that. So we just found the solution for 2 to the 1.8 by using the smooth graph of y equals 2 to the x. Now the solution to the exponential equation for 2x equals b. Remember, during the last section, 3e, we talked about graphing as a way of solving this equation where you have an unknown exponent is equal to a number. So if we have like 2 to the x equals 5, then what we can do is we can find we can find 5 on the y-axis, and then we can see that it maps to 2.3 on the x-axis. So that we solve this with that. Okay. So now I'm just going to solve a few examples for you. Use the graph above to estimate the value of, and so let's see. We'll take this one, 2 to the negative square root of 2. Negative square root of 2, remember, is like negative 1.414, something like that. So we have 2 to the negative 1.414. And so if we look on the graph here, we have negative 1.414. That is the x value, right? So we would put it about there. What is the y value equal to? Well, it looks like it's about 0.4, maybe 0.35. So we could say it's 0.35 maybe. All right. Use the graph above to estimate the solution to, and they give us 2 here. Let's do 2 to the x equals 0.6. So we take 0.6, it's about there. And that would be about equal to, let's see, maybe negative 0.7. Maybe. Okay. Use the graph of y equals 2 to the x to explain why 2 to the x equals 0 has no solutions. Let's see, 2 to the x equals 0. That's when y equals 0. That's right here. When is the exponential curve equal to 0? Well, actually, it never is because it's an asymptote. So it just approaches it and it never touches it. So you could write because y equals 0 is an asymptote. So 2 to the x never touches it. Something like that. Okay? 4. Draw freehand sketches of the following pairs of graph using your observation from the Desmos investigation. So you need to think back to your Desmos investigation. Maybe you could open it up. But let's see. We'll take this one. Y equals 2 to the x and y equals 2 times 2 to the x. So remember, in one case you got an exponential, and then you're multiplying this one just by 1, right? So it's like you're comparing 1 times 2 to the x to 2 times 2 to the x, right? So what's the difference between these two? Well, remember that at x equals 0, this part with the exponent just becomes 1, right? Because anything to the 0 power equals 1. So if we make this equal, we make this like the x-axis and the y-axis, let's graph this one first. So at x equals 0, this thing equals 1. At x equals 1, this thing equals 2. And then 4, and so on. So this one is just equal to, a very quickly rising curve there that goes through 1. Now what about this one? When x equals 0, this one, when x equals 0, this one equals 1 times 2. So actually it's equal to 2. And then when x equals 1, this one is equal to 4. And when x equals 2, this one is equal to 8. So if we graph these points, 0, 2, 1, 4, and 2, 8, it's rising much faster. Okay? So, and remember, the meaning of the multiplier in front, which is this one here, it's equal to the initial value. So if the initial value is 1, then you have a 1 multiplier in the front. And if the initial value is 2, you have a 2 multiplier in the front. Okay, so remember that was from our investigation. Draw freehand sketches of the following pairs of graphs. We have y equals 3 to the x and y equals 3 to the x plus 1. Now remember, when you had the k value here, when you add the k value, it basically just moved the graph up and down. So if we have y equals 3 to the x, we would graph that as, let's see, 3 to the 0 is 1. And I'm just going to draw the x and y axis here. And so if we put 1 in here, then it would be 1, 3. If we put 2 in here, it would be 3 squared, which is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then if I graph that, it would be like that. And then what about 3 to the x plus 1? Well, 3 to the x plus 1, everything would just be plus 1. So this would be plus 1, this would be plus 1, and this would be plus 1. And so it would be similar, but it would be moved up. Okay? So that makes sense, right? During the investigation, we saw that if you add a number here, that it simply raises the whole thing up. It's a way of moving the graph up and down. And in fact, not only does it move the graph up and down, but the horizontal asymptote is also moved up and down. So the horizontal asymptote in this case is going to be y equals 1 instead of y equals 0. Let's see. For each of the functions below, sketch the graph, state the domain and range, use your calculator to find the value of y when x equals square root of 2, discuss the behavior of y as x approaches negative or positive infinity, and determine the horizontal asymptotes. Okay, so sketch the graph of the function. So we know, and we can like put, let's see, I'm going to do the second one here. So let's see, it's got plus 3 on it, which means everything is plus 3, including the asymptote. So the asymptote for this function is going to be at plus 3. Okay, and let's see, let's plot a few values then. So x, if I put x equals 0, it's going to be 1 plus 3, which is 4. If I put x equals 1, it would be 1/2 plus 3, which would be 3.5. And x equals 2, that means it would be 2 to the negative 2, which is 1/4 plus 3, which is 3.25. Okay, you can see that on the other side, on the right side of the y-axis, it's getting smaller. What about -1, -2? So if we put -1, it would be 2 to the positive 1 plus 3, it would be 5. With -2, it would be 2 squared plus 3, that would be 7. So let's plot these values. So -1, 5 would be here. -2, 7 would be here. And of course 0, 4 would be here. And 1, 3.5 would be here. Okay, and then so you can see that it's going to look like that for this one. Okay, so and is that as predicted? Yeah, because If you have a negative x here, it's decreasing. If you have a 3 here, that's the horizontal asymptote at plus 3. So that's kind of what we're expecting, yeah. Okay, and that's sketching the graph. State the domain and the range. Well, the domain is any number, right? Because that any x can be the domain. The range would be any number above 3, so it'd be y equals 3, right? Y is greater than 3, sorry. The asymptote would be y equals 3. And use your calculator to find the value of y when x equals square root of 2. You could just like turn on the calculator here, and we would say 2 to the negative and square root of 2, 2 to the negative square root of 2, which would be 1.414, plus 3. So our value would be 3.38. Okay? Discuss the behavior of y as x goes to negative or positive infinity. Well, when x goes to positive infinity, we can see that it approaches the asymptote y equals 3. Okay, so positive infinity, or sorry about that. X goes to positive infinity. That means that y goes to the asymptote of 3. When x goes to negative infinity, that means that y goes to positive infinity. Determine the horizontal asymptotes. We already said that that's y equals 3, right? So that's that one. And that is the end of this lesson.